Good evening. I am Mary Pettigrew. I'm part of the communications team for Empower Our Future. I'm pleased to be joined this evening by Chris Hoffman, also part of the communications team, as is Steve Whitaker and Paul Cullen, our wonderful kind of behind the scenes technical guy who makes all this happen. Really appreciate everybody. And I will go ahead and start with our land acknowledgement. We acknowledge with respect as non-native people that the land on which we stand, live, and learn is the traditional territory of the Ute, Cheyenne, and Arapaho peoples. We also recognize the 48 contemporary tribal nations that are historically tied to the lands that make up the state of Colorado. We honor elders past, present, and future, and those who have stewarded this land throughout generations. We also recognize that our government, academic and cultural institutions, and our nation itself were founded upon and continue to enact exclusions and erasures of Indigenous peoples. May this acknowledgement demonstrate a commitment to working to dismantle ongoing legacies of settler colonialism, oppression, and inequities, and to recognize the hundreds of Indigenous nations who continue to resist, live, create, and uphold their sacred relations across the lands. Let us seek to understand what it means to be in right relationship today with the traditional stewards of this land and with this land itself and with all the creatures that inhabit it. And without further ado, I am pleased to announce our speaker this evening is Greg Fisher, a Fort Collins architect. He's a LEED accredited professional and active member of the Passive House Network. Since about 2016, Greg has been passionately involved with Passive House and the principles it promotes to create healthier, more comfortable, and energy efficient environments. Greg is the founder of Greg D. Fisher Architect, an award-winning firm established in 1993. His practice focuses on simple, progressive, authentic, and responsible designs. In 2019 and 2020, Greg took a sabbatical to design and personally build one of the first Passive House Institute certified homes in Northern Colorado, and he is apparently still living in that home. So again, thank you, Greg, for joining us. It's all you.
Thank you for that introduction, Mary, and hello, everyone. Yeah, and Mary is correct. I am actually sitting in that Passive House currently. It's not the most glamorous view you see behind me of the house, but nevertheless, I'm in it. I'll tag on a couple of other facts too. I am also a certified Passive House tradesperson, or CPHT, as well as a certified Passive House designer, or CPHD. So those things, in addition to building my own home and working on several projects, provide me with a fair amount of experience and testing and certification. But I would tell you, this Passive House rabbit hole is very deep. And so I find I'm still constantly learning. Things are continuing to evolve. So it's a ever-changing and improving landscape, as well as a deep rabbit hole to go down. So thank you all for joining the presentation. I hope it leaves you thinking differently about building. So a little bit about the Passive House Network, which I'm a member of, and who's basically behind this presentation. Passive House Network is a national nonprofit educational organization affiliated with the Passive House Institute. The network is comprised of regional chapters and connects global knowledge networks with regional needs and local applications. We have 6 chapters in the US, including the Rocky Mountain chapter, which is for our region, excuse me. So let's begin. Today we face interrelated and interlocking crises, environmental, health, and social crises. And while how we deal with them or not is an individual choice, we all should be able to recognize the power of buildings to help solve our problems or exacerbate them. Passive house alone is not the solution to anything, of course, but it can be part of the solution. What's different with passive house is that it is uniquely recognizes, embraces the power buildings possess, what the architectural structural holds, and empowers architectural solutions to fundamental problems. We must eliminate carbon emissions. With passive house, the architecture itself can drive energy efficiency. We must protect health. Passive house places hygienic indoor environments as part of its foundational concept. We must provide storm resilience, and passive house provides the most robust shelter in place potentially possible. We must provide affordability. It cannot be for the 1% or the 10%, but for all people. Passive house provides affordability, both in initial costs and, of course, in long-term operation and maintenance costs. And in these uncertain times, we need to mitigate future risks. Let's put it out there, future risks to our investments. Whether it's down payment on our first modest home or an organization funding big commercial building projects, buildings are huge investments, typically our biggest investments. Today, with fast and changing environmental and regulatory conditions, these investments face an incredibly uncertain future. How do you lower your risk? Build a passive house. Passive house cuts through the twists and turns and gets you over the horizon to the goal line. We're headed to a zero carbon future. With passive house, we can build to meet that future today. With passive house, you can future-proof your buildings. The goal of this short presentation is for you to better understand what this all means and how it's all possible. Understand how you can utilize passive house to make the change you want to see in the world. We hope you'll never be able to look at buildings the same way again. So taking a step back, what came before passive house? What's the prehistory? Our passive house didn't spring out of nowhere. It was formulated based on a long history of efforts. Not surprising, like so much received wisdom, it starts with vernacular architecture. And the example here in southern China is of particular relevance because it was the study of the performance of these buildings that helped inform the work of Bo Adamson, a Swedish academic launching the passive house idea for a research project in Europe. Another interesting example is the Norwegian polar explorer ship, the Fram, which contained all the principal strategies of passive house building, with fresh air and the occupants' comfort provided by only a single lamp burning. And they even ripped out the stove after a while. In Denmark, the DTH Zero Energy House provided valuable experiences directly incorporated into the start of passive house research. In Germany, a super insulated experimental home showed the potential of passive measures providing energy savings on the order of 10 to 20 times in Europe and America. And in the US and Canada, pioneers like Wayne Schick, William Sherclough, and Amory Lovins, who you probably know from the Boulder area, Harold Orr and others, pushed super insulated developments in the 70s and 80s. These and many more examples were the precursors of the birth of the modern passive house. We should note here as a clarification, sidebar of sorts, that none of these precedents were what we call passive solar buildings, those that proliferated in the 1970s. These precedents are not overglazed and rely more on a balance to achieve with super insulation. It's understandable that people may mistakenly draw a direct connection between passive solar and passive house because of the similarity in the name and use of passive solar heat gains, but the connection causes endless confusion and wrong-headed assumptions. A more apt comparison might be to someone confusing an electric golf cart for a Tesla automobile. They have their similarities, but occupy much different realms of development considerations. So the first passive house you can see here was built in 1990 as a research project, a physics experiment in Darmstadt, Germany, by a national team led by Dr. Wolfgang Feist, who's the founder of Passive House Institute, and included Bo Adamson and many others. It was and is composed of 4 attached row houses, complete with custom building components developed for the experiment. This research solidified the underlying principles and strategies that would become the passive house standard. The story goes that Amory Lovins from the Rocky Mountain Institute visited this building and provided the insight that these new developments could be standardized and scaled to great effect on the building industry. And from that time on, the Passive House Institute has continually conducted research, developed tools, and worked with industry and government partners worldwide to make passive house buildings the new normal. So what changed? What was the discovery of this passive house experiment? What flipped in our thinking? What came out of this research was the essential power of the passive house concept, that despite our focus on energy efficiency and seeing comfort and health as a result of efficiency as side benefits, it is instead the focus on occupant comfort and health that drives performance. In other words, it starts with the occupant. Per the purely functional or idealized definition as it was distilled, quote, a passive house is a building for which thermal comfort can be achieved solely by the post-heating or post-cooling of the fresh air mass, which is required to achieve sufficient indoor air quality conditions without the need for additional recirculation of air. This describes maintaining comfort and health with 100% fresh air with a very low capacity for heating and cooling energy. You need a very energy efficient building to achieve this. Consequently, health, comfort, and efficiency are all working in this direction, all supporting each other. So we have what's really a comfort and health standard producing an energy standard, the passive house standard. This diagram is for homes, but it could easily be for any type of building, with heat losses below the middle line of the equilibrium and heat gains above that same line. We could also flip this to be about cooling in a hot climate. In the old, very leaky and moderately leaky, shall we say, homes, large active heating systems are required to bring the building into balance, as the gains above must equal the losses below. While the passive house building requires a tiny fraction of the energy to be brought into balance. This dramatic reduction in heating and cooling demand demonstrates the power of optimized passive architectural structure and will flip our expectations. It's like what we've experienced with our computer industry, where computers get ever more powerful while using much less energy. And so too, passive house decouples power from performance. Passive house provides a clear pathway to decouple and frees us to deliver zero carbon buildings today. This is a game-changing thing. Let's look at what passive house delivers now. The passive house concept starts with the occupant, as we've said, and moves outward. What makes us comfortable? How about steady temperatures? How about no drafts, no cold feet, peace and quiet? How about sitting by the window on a cold winter day and still feeling comfortable like these two girls are? Passive house provides hygienic indoor air quality, 100% fresh air and exhaust with no recirculation. It's filtered fresh air, keeping pollution out, no mold and associated illnesses, reduced asthma and reduced allergies. Passive house provides resilience that we can shelter in place indefinitely in the winter and in the summer for an extended period of time, long enough for the power company to get things up and running again. And I've personally experienced that in my own passive house where we've had some outages and we've been nice and comfortable here for 2 to 3 days before noticing a problem. This is an example from a home in Brooklyn, New York, several polar vortexes ago. The black line is the exterior temperature driving down and staying freezing for 4 days. The red line is the interior temperature, not a flat line, but steady. And we see the one moment when the family turned on the heat during the week where there's a bit of a spike. Passive house supports equity by delivering high quality, comfortable, and healthy homes that cost dramatically less to operate. The dramatic reduction in energy usage also protects people from possible future energy price shocks. This is an affordable housing development for seniors in Queens, New York that you're seeing here. Also has a pre-K school on the ground floor. Passive house first scaled in Europe with affordable housing projects, and today in the US, we see affordable housing advocates incentivizing and encouraging passive house building. Passive house supports our country's transition to a green grid and electrified future. The dramatic energy reduction of passive house makes removing fossil fuels from buildings economical. And with renewable energy options available on-site and off-site, passive house makes grid utilization more efficient and resilient. Consequently, the more passive houses we build, less renewable production is ultimately needed, making our green transition more affordable and quickly achievable. To achieve the wide range of benefits a passive house building can provide, passive house doesn't look to more power first to solve problems. Instead, as designers and builders, we re-engage the passive building elements, the architecture, the structure itself, and empower it to do the heavy lifting. As you would first place the fulcrum of a lever in the optimal position to lift a weight before applying power to lift it. In our case, think of the enclosure as the fulcrum, and how we formulate the enclosure, like the placement of the fulcrum, has an equally profound effect on the power needed to provide comfort and health. This flips our business as usual thinking. Consequently, Passive House does not make us think and work differently. Passive House asks us to question everything, to effectively restart, like going back to the ancients. How do we optimize and empower the elements to do this heavy lifting? And this goal, the quest of the unlocking power of the passive building structure, re-engages our focus with the ingredients, the recipes, the materials, the details, and the craft of building. It empowers and energizes the project team, from the owners to the designers to the builders and construction site laborers alike. Nothing is taken for granted. And this quest for passive building power has us designing and building with the energy flows and energy balance, not as a far off abstract concepts, but instead as active tools that inform everyone's work. And once we've decided to grapple with the idea that our architecture can produce such profound and far-reaching results, the challenge is really a simple question. Do we have the imagination? Do you have the imagination it takes? Don't be deceived by what you may or may not think is possible. Passive House is just starting. Like stone builder of the medieval times, who could have imagined that working in stone, they could develop the flying buttresses that they could effectively dematerialize walls like you see here in the Chartres Cathedral. It was an astonishing transformation, perhaps unimaginable. Today, Passive House is evolving rapidly. So let's move the frame of reference. Let's look at towers and shake our preconceptions about what is Passive House building and what might be possible. Here we have, from left to right, a bank headquarters in Vienna, then a Midtown Manhattan high-rise mixed affordable and market rate apartment building, and then a 60-story residential tower starting construction in Vancouver. And on the right, a mixed-use high-rise under development in Boston, not your typical Passive House. And more so, here's a garment factory in Sri Lanka, which is Passive House certified. And of course, there is housing. There's an affordable housing development in Norwich in the United Kingdom that won the Royal Institute of British Architects' highest award, the Sterling Prize. So here we have affordability, performance, and architectural design that is recognized all in one package. So with these few examples, I hope we can shake off any of our residual self-imposed artificial limits on what's possible. Passive House is no more a constraint to great design than any other programmatic element you're tasked with delivering. Key question, how much does it cost? But beyond imagination, we should also address this. Upfront, the very real and concrete concern of cost. After all, it has to be affordable to be successful, right? So how much does it cost? And here we have to change our thinking as well. Passive House is not an ad alternate in the bidding process. It will fail in that direction. Passive House is not an upgrade. This too will doom it in the project. Instead, Passive House is a fully integrated approach. It is the only way to succeed. It's not the cheapest either. This is high quality construction, for heaven's sake, but it's affordable high quality. And as a fully integrated goal, experience shows that the Passive House related decisions can actually drive down costs as much as they might raise costs. In fact, there's so many other decisions in a given project that have a much greater impact on the ultimate project cost. Passive House shouldn't break the budget, it should fit in your budget. Let's note in this graph, this demonstrates the lack of direct correlation between passive houses, which are the blue dots, and non-passive houses, which are the black dots, and cost. In these examples, Passive House, was not an add-on, but an integrated goal, and it shows the average cost of the passive houses to be less expensive. Of course, I don't know all the decisions made in all of these structures, but clearly optimization and designs and construction are driving affordability. However, let's not count on it being cheaper. Don't eat as nutritiously as we should, don't exercise enough either. And at least most of us don't. And let's not assume we're going to optimize our passive house enough. It's life, right? So let's aim for affordable, not the cheapest, maybe even a bit more. And what Passive House Network is seeing is that a 3 to 5% increase in project costs can be a reasonable baseline. I've seen a bit more in my own projects, but nevertheless, that's coming down. Let's say a few brief words on staying on budget. Passive House must be included at the very conception of the project, like mentioned earlier. You must really work with your Passive House building certifier from the beginning, and benefit from their institutional knowledge. Don't dig a hole on day one that you have to get yourself out of. Require the team of professionals and builders to have proper Passive House training. Optimize from the start and stick to getting certified. Stick to that target. And if team members are feeling like something is just too tough or seems impossible, it could be that lack of experience and known references is inhibiting them. Get them to reach out, find examples and experiences around the world. They're out there because while Passive House is young, there's a world of experience to benefit from. The global Passive House community is generous in sharing information. Use that information.
Greg, this is Chris with Empower Future, and you asked to be given questions if they arise in the Q&A. And here's one related to what you've been talking about. It says, Colorado is focused on beneficial electrification and heat pumps, but giving very little focus to the potential for design to reduce our need for natural gas. Are you able to help the Colorado Energy Office and others at the state level start to think about the benefits of Passive House design for helping us move off of fossil fuels?
Yeah, I think this is an excellent point in question. And yes, lobbying is being done in several aspects of this question with both officials in the state of Colorado as well as throughout the United States. Advocacy is something I firmly believe in, but it's not something that I am a well-practiced practitioner of. But there are many people in the Passive House Network that are working strongly on that condition. So thank you for.
Thank you for that.
Thank you. So how is this possible? Easier said than done, right? May seem impossible on its face. I mean, how can you beat it cost parity or close to cost parity and have all these amazing benefits? The key is predictability. You can fully optimize the performance and economics if you have a strong sense of predictability. If you can calculate accurately and execute to a clear plan. So the Passive House Institute didn't just give us this new concept and say, hey, go to it, good luck, but instead provides a pathway, a methodology, and a wide growing number of tools to enable predictability. Building certification is critical, but there is much more to it. There are component certifications of essential components like windows and ventilation units. Be sure to check out the database of thousands of certified components on the Institute's website, and critical personnel certification on the design and construction sides. The PHPP energy model, PHPP standing for Passive House Planning Package, Passive House Planning Package, it's an active tool in the design of the building. Reference materials abound from the Passipedia, the building database, and other corners of Passive House PHI's vast website. And PHI conducts ongoing cutting-edge research around the world with new uses, climates, new technologies, and new methodologies. The Passive House Institute has over 60 employees from all over the world, many of them not just building scientists, engineers, or architects, but also physicists. And it's an extraordinary brain trust that you have the opportunity to work with. The knowledge is widely shared through many channels, including International Passive House Association, of which PHN is a part. Your membership in the PHN makes you also a member of the International Passive House Association. It is also possible because the pathway includes very clear certification targets with metrics that include comfort, health, and energy. These are not relative targets set to a baseline that can be gained, but hard targets that leave you knowing where you stand. Today, the targets include increasing levels of renewable energy production integration and greater efficiency. Buildings built to be future-proof. The certifications also extend to retrofits with the Interfit standard, also including higher levels of performance and renewable energy integration. Interfit provides flexible pathways, including a step-by-step strategy that allows for phasing of work in sync with the replacement cycles of the building systems, ensuring that passive house performance is the end result. Basically, Interfit acknowledges that it's more challenging to retrofit a building than it is to build new. We mentioned the building certifiers early in relationship to controlling costs, and the importance of their role cannot be overstated. We are fortunate to have many independent certifiers operating in the United States today. They work cooperatively, sharing experiences and information with each other, and the certification process from day one of your project is critical to making success normal. And a side note, but an important note, we see today more and more buildings claiming to be passive house buildings, where they are advertised as being built using passive house principles. Be skeptical of this. We see these buildings that are alleging to be passive house buildings falling short of owner expectations. So buyer beware of this. If the building is not certified by one of these certifiers, your risk of not meeting your targets, your risk of producing a gap in performance can go up significantly. Not to say that they all are, but that can be the case. And you now may be saying to yourself, okay, that's all well good. How do we actually do this? Let's dive into that. As we've noted, we need to re-engage the passive building elements, the architecture, the structure itself, and empower it to do the heavy lifting. Reclaim the power of the architecture. The Passive House Institute provides an integrated methodology that organizes the work and keeps you on the path. The methodology focuses initially on the enclosure, then ventilation, and lastly on active heating and cooling. We'll look at the role of insulation and thermal bridge-free connections. A thermal bridge is basically where there's a break in the insulation and heat can more easily escape, like a cold metal window frame in winter. We'll look at air tightness, high performance windows and doors, and high efficiency, high recovery ventilation. These are key ingredients or principles of passive house. These key areas and more are all entered into the Passive House Planning Package, or PHPP energy model. The PHPP is an Excel-based tool which allows the designer to simulate the behavior of building both during peak times, winter and summer, and over an entire year. This flexible model allows for quick iteration and design alternate evaluation. The PHP and all other simulations should be implemented not just as compliance tools, demonstrating that building meets the standard, but as designs tools which allow the team to iterate and evaluate a host of ideas and options, real-world assumptions, and possible future scenarios. This doesn't mean that the PHPP controls the design, but rather that it helps to inform the design with performance data throughout the process. This is the essence of data-driven design, frankly, of good design.
Greg, here's another question that's come in. It says, I understand that there is an international design code for passive house design, but that it's rather rigid and difficult to implement. Is that true? And do you advocate adhering to that code, or are you in favor of other less rigid design principles? I get concerned about resistance to requiring another building code.
Yeah, legitimate question. What I would first say is that Passive House does not mandate how you build. Passive House mandates how the performance or how the building will perform once you have built it. So there are many, many, many ways to skin the cat of creating a Passive House certified building. You just have to live up to the performance criteria, which has to do with the amount of energy consumed for heating, the amount of energy consumed for cooling, how airtight the house is, and how and having the house properly ventilated so we don't have sick building syndrome from folks getting sick inside. So when I think about this as a building code, or the question is about this being a building code, I don't see it as a code. I just see it as a performance mandate, and there's many ways to get there. Not to say that there aren't very good and impressive buildings that are being built that are not built to Passive House standard, but I believe the Passive House principles are very important in achieving. And I also believe that modeling using the Passive House planning package that we talked about and some other tools is the only way you can really prove that you are meeting those kinds of standards. So even if you don't certify at the minimum, doing this modeling, proves out your principles of meeting those goals. It also, like I mentioned earlier, it allows you to experiment with different alternatives to meeting those goals, while still accomplishing the rest of your goals. For example, maybe you want to have a lot of, have more windows on the north side of a home that might be advised by Passive House because you've got a really spectacular view to the north. So we might play with a little bit more window on the north, otherwise when it's against the principles, but we offset that by having a greater amount of insulation in the walls to accommodate that. So there's really a lot of flexibility within the system as well.
Thank you.
Sure. So taking a closer look at the ingredients being entered into the PHPP, we first start with right sizing continuous insulation. Generally, this means more insulation than normal, but not always. The idea is what you want to insulate to where the idea is that you want to insulate to where you don't just shiver less, but you're actually comfortable. Typical buildings are like an undressed teenager wearing nothing but a hoodie in midwinter. They'll survive, but we really want to live like that. You know that if you wear the right layers and a good parka and a hat and so on, you cannot just get by in the cold, but actually be warm and comfortable. Our Passive House is the same way. Or another example is to think of it as a temperature rated sleeping bag, all surrounding the conditioned space. Second principle of Passive House then extends this thinking to make sure we don't have breaks in the insulation. In typical construction, thermal bridges may not seem important in isolation, but they can completely undermine the building's performance when you add them all up. If we think of a thermal bridge as a cut, your project can easily die from 1,000 thermal bridge cuts, so to speak. Here's some examples of thermal bridges, and they abound, but the thermal image on the lower right shows the common balcony connection, turning the building into a radiator to the world. So what you're seeing there is basically the heat being conducted out of the building and into these balconies and then radiating out. The colder interior surfaces can cause condensation, as we can see on the window frame in the upper right, and worse yet, mold on the left. To overcome these issues, typically we overheat, treating the symptom with brute force. With Passive House, we first avoid the problem in the first place rather than treat it. Thermal bridges typically occur at junctures where the floor meets the wall or wall meets the roof, or at window frames meeting walls or balcony connections. The energy loss causes thermal discomfort and condensation and moisture damages. Traditional energy models don't account for thermal bridges and is a big contributor to the oversizing of mechanical systems, just to be safe, so to speak. In Passive House, we look carefully at all of these connections and junctures, working through the construction details, and eliminate the thermal bridges entirely or minimize and calculate them if we cannot eliminate them. We include them in our PHPP energy model, and this results in increased predictability and produces lower risk construction. The third principle is an airtight enclosure. And while when the subject comes up, people might reflexively touch their necks and worry about poor indoor air quality and perhaps succumb to nightmarish imaginings of not being able to open windows, we need to set the record straight at the start. Two concepts are in play: quality indoor air and our freedom. And so we need to flip the common and wrong-headed thinking on both. First, let's address quality. The fundamental idea at work here is that it is very difficult to control the quality of something if you don't first have control of the thing itself. If the enclosure is leaky, the polluted outdoor air is moving willy-nilly through the building. Consequently, the only way to have any sense of control is to overcome it with power. never sure if this space or that space is properly ventilated, like thermal bridges where we're treating the symptoms with more brute force. But in an airtight environment, the air is under control and we can very differently and confidently maintain its quality. Airtightness sets the table for healthy indoor environments. But you might say that's all well and good, but the passive house police won't let me open the windows. It's fascism. Quite the opposite. Of course, there are no passive house police. You can open the windows, but let's think about it. You often open the windows when the indoor environment feels unhealthy and uncomfortable, and you need the fresh air. It's not a want, it's a need in those cases. But in a passive house, you have clean, fresh air, whether the window is open or closed. You don't need to open the window. You open a window because you choose to. It's a lovely day. Open the windows and let the breeze blow through. How nice is that? Passive house is actually giving you the freedom to choose. So with that straight, let's take a moment to talk a bit more about air tightness and why it's so important. And it's because it profoundly affects so many fundamental aspects of building performance. We've just spoken about supporting indoor air quality. What about comfort? Well, it eliminates those annoying drafts we need to overcome with large mechanical systems. More brute force, treating the symptoms. Air tightness also protects the enclosure from moisture damages. Air tightness radically reduces heat loss. If we take two buildings, both well insulated equally, but one is leaky and the other is passive house airtight, the difference in heat loss could easily exceed a magnitude of 5 times. 5 times the difference. They become totally different buildings based on air tightness alone. And so if in your energy calculations, design, and construction, you can confidently provide greater air tightness, don't just hit the passive house air tightness go, hit twice the air tightness. That first passive house in 1990 did. And you can eliminate lots of insulation. Teams that are proficient in providing air tightness can achieve huge enclosure cost optimization and savings. And in hot, humid climates, air tightness keeps the humidity out and reduces the demand for dehumidification, allowing the cooling system to be sized mostly for cooling as it should be. For all these reasons, the truth is that a building can never be too airtight, and passive house takes full advantage of this truth. Fourth principle is high performance windows and doors. The flip here, as we spoke in the beginning, is to rid ourselves of the unfortunate association people make with passive solar buildings. And we must always be on guard to avoid overglazing and the accompanying overheating. The passive house solar buildings of the 70s and onward were overglazed, out of balance, and often very uncomfortable. If you can recall, the precursors to passive house in the 1970s were not passive solar buildings. They tended to be super insulated buildings that balance daylighting needs and solar heat gains and losses. Passive house buildings don't have tiny windows either. We're not building caves. Expansive views abound. We will utilize passive solar heat gains, but we are being very conscious about the energy balance, about solar protection and the consequences. Restraint might be a good word for what we're showing off. Key concept here is that the windows and doors act not simply as a provider of views and daylight, but they're a critical component in our continuous insulation and air tightness. The windows themselves are often triple pane and truly thermally broken and airtight with 3 layers of gasketing typically. The window connections to the surrounding construction and airtight insulation control layers must be airtight and insulated. Thermal bridge free connections, of course. This all gets you deep into the construction details. Passive house windows can come in any type: metal, wood, metal clad wood, PVC, and fiberglass. There are dozens of suppliers in the US market now, and there are several North American manufacturers producing passive house certified units. Be sure to check out the certified component database on the PHI website, passivehouse.com. Window quality is a primary driver of comfort, of course. And while there are a myriad of factors, the fundamental idea here is that our typical windows, our code windows, result in significant temperature asymmetry. In winter, the window is colder than the other surfaces and you feel it. It causes convective currents, and this needs to be overcome with perimeter mechanical systems. With passive house, the windows are of a quality that the temperature is close enough to avoid discomfort and avoid the need for mechanical systems to compensate for this. Because windows are such a critical component and their performance cannot be compromised, we recommend the Passive House Institute certified windows are the ones that you utilize. Like airtightness, high quality, high performance windows disproportionately affect the overall energy balance performance of the building. They offer greater design freedom, flexibility, and options. They provide value that cannot be appreciated in an isolated budget line. And while windows provide our views in daylight and yes, useful passive heat gains, improperly designed windows can cause significant overheating, causing discomfort and additional air conditioning requirements. And we know that overheating is a common problem in conventional buildings across the industry today. The best approach to avoiding overheating is to carefully provide proper shading. Shading can be provided by how the window sits in the wall, an architectural element, or using landscaping. Needed shading can be achieved with interior blinds, but exterior shading is the most effective, keeping the heat out. Shading cannot be an afterthought. It cannot be optional. It has to be design integrated. The fifth principle is high efficiency heat recovery ventilation. So let's think back to the definition of passive house. The primary goal was to ensure effective hygienic ventilation. Today, and in the recent times of coping with the COVID-19 pandemic, hygienic ventilation has been a hot topic. Add to that the inescapable forest fire smoke and the long history of poor health outcomes for marginalized communities on the fence line of industrial production. And of course, hygienic ventilation should be a foundational goal. And remember also that what is going to set us up here for success is the airtight enclosure. There's no pollution entering willy-nilly as happens in typical construction. We have control of the interior air. Now, typical buildings have ventilation systems, just bad ones, often providing only intermittent exhaust from bathrooms and kitchens that don't ensure good ventilation everywhere. And in commercial buildings, often includes a lot of recirculated air. In a passive house building, we supply 100% fresh air to every served space, bedroom, living room, office, classroom, etc., and 100% exhaust from every service area, bathrooms, kitchens, utility areas, and this all operates continuously 24/7. The systems are laid out to ensure that all spaces have robust ventilation. Again, there is zero recirculation. Now, such a system of 100% air changes would normally be prohibitively expensive to operate because typically you need to heat or cool that fresh air to maintain comfortable interior conditions. But this gives us the passive in ventilation because there's a passive heat exchange element located with the fan unit. This allows the heat and energy from the outgoing airstream to move to the incoming airstream. And today, the efficiency of this passive exchange can exceed up to 90% or more. This means that on a cold winter day, the fresh air supply without any added heat enters the room within just a few degrees of the room temperature, ensuring occupant comfort. And Passive House Institute certified ventilation units ensure that you get the performance and cost savings you expect. In looking at the energy balance of the buildings and the building design, we're also going to look at the things that provide internal passive heat gains as well. Things like people, appliances, and equipment, the lighting and mechanical systems, because they can contribute significantly to providing the heat needed in winter. It all goes into that PHPP model we talked about earlier. So at this point, moving through the building design, the metaphorical fulcrum is pushed as far as it can go. The architectural design and other passive elements are doing the heavy lifting. Like the Gothic cathedral we looked at earlier, the architecture is doing the work again. We've minimized the need for active heating and cooling and dehumidification. But depending on where you are, there will likely be a need for active heating, cooling, and maybe even dehumidification, just greatly reduced. It's important to remember that this is about optimization, not magic tricks. So what we see is the ability to meet the occupant needs with a 75% reduction in mechanical equipment sizing and up to a 90% reduction in usage of energy. We can pull the distribution to the core of the building, and because the loads are so low, electrifying everything is economical. We can get rid of the hydronic heating if we like and provide heating and cooling from a single heat pump system, as the questioner was asking about earlier. The only trick here is perhaps getting the mechanical engineer to agree with the plan, because at first glance, they might see a building that will fail. I mean, how could it not with such a small mechanical system, right? It can take a few meetings, but with careful explanations, even engineers who are we've seen initially energetically opposed can become ardent supporters. We need all engineers out there on board. We can't do it without them. And then there are smart systems. Isn't opposed to incorporating smart systems and technology. Even the first passive house had to have a CO2 detector to help control proper ventilation. But the smart system should enhance high performance. They should not be used to compensate for poor performance. So let's make the architecture do the work. Let's incorporate only the most efficient equipment, and let's add smart systems as we like, but always with an eye towards greater simplicity. Let's simplify, simplify, and simplify some more, because our resilience depends on it. So this methodology described has global applicability. It's being applied all over the world, and the basic principles have local solutions. We're grappling with that global crises, and we can all work together around the world, learning from each other to address them. I'm going to wind down here with looking at a few examples of the great variety of passive house buildings underway around the world. In China, passive house is exploding, and here's an example of a guest hotel for a company south of Beijing. In the UK, in Exeter, they're building a municipal leisure center with a big indoor swimming pool. And it should be noted, in Exeter, the city builds everything to passive house standards: affordable housing, schools, administrative buildings, and now even a new leisure center. And here's a building in the Congo, which is not a place you'd necessarily expect to find a passive house building, but you would in Belgium. So when the Belgian government planned their new embassy in Congo, they made it a passive house. And here's an example by Grimshaw Architects of an academic building at Monash University in Melbourne, Australia. Sophisticated and affordable housing in Philadelphia. That is net zero from on-site renewables. And here's a single family scale building, although it's a retreat for musicians. Truth be told, in Vermont, beautiful thing. And it also shows that a modest building in a tough climate can be filled with light, have great views, and serious architectural expression. We can have it all. We just need to imagine it and work for it. And I also understand that some of you in the audience might be considering building a church. And here's an example of a passive house certified church in Kingsland, east of England, UK, built in 2018. Here is my personal passive house and office in Fort Collins, and where my wife and I have lived and worked very comfortably for almost 3 years now, and where I'm sitting currently. So as the world heads toward climate tipping points, and we plainly see the interconnections of these crises, let's have the imagination and determination to seize the inherent power of building and really leverage it, so that we can confidently deliver better health outcomes, support greater equity, and deliver climate action proportionate to the emergency. We see the push to zero carbon emissions on the horizon across the board and coming at us fast. Let's not wait another day, but instead let's set ourselves up to meet that world by building passive house buildings now. So are you thinking differently? Are you ready to act? I hope so. And I hope to see you at future Passive House Network, Passive House trainings and events. Speaking of those events, I wanted to make you aware of a few things that are coming soon here to Colorado. The PHN National Conference will be taking place in Denver in September, late September and early October. And then something coming sooner here, the Icebox Challenge will be in Fort Collins in the beginning of July, in Louisville in the latter part of July and August, and also in Denver in September. And you might ask, what's the Icebox Challenge? It's basically a situation where we build two small structures, about 7 foot by 7 foot by 8 foot. We build one of them to the Passive House standard, and we build one of them to the local code standard. We put 1,000 pounds of ice in each structure and leave them sitting out in the sun for about 2 weeks. And after 2 weeks, we unveil the results, and we monitor the weight of the ice and show, tangibly demonstrate how Passive House improves the performance of these buildings and helps maintain the ice. And more importantly, it even, they work better as keeping the cold out in the wintertime. So with that, I'm going to close, and I want to thank you for your time, and certainly be happy to answer any further questions.
Greg, that was wonderful. Thank you very, very much. And one question has come in right now. How did you get started with Passive House?
Yeah, thank you. Well, I actually had sort of a shift in my whole thinking about green aspects, sustainability, spirituality, politics, everything probably around the turn of the millennium. And so that set me on a path to trying to build green and build better. And that path led me lots of different places. It started with being heavily involved with LEED, which many of you are probably familiar with. Moved into other things like the Living Building Challenge, which is sort of a more intense out version of LEED that was more about rather than doing less harm, it was about actually doing good and being regenerative. That led me into some other organizations, and then I became aware of Passive House, I don't know, probably 10 or 12 years ago, and like the path of Passive House, relative to those other paths, particularly for building my own home, I felt it was the most rigorous and the most science-based approach to trying to really measure what we're doing. That's not to put down the other certification standards. I believe strongly in them still, and all these standards have different strengths and weaknesses. The thing I would say, like about Passive House, there's some things that it doesn't address that LEED or the Living Building Challenge does address, more holistically. But I don't think any of the systems out there address performance and indoor air quality any better than Passive House. And then you have these great tools to be able to prove it out as you're in the design process that are so meaningful.
So thank you. And the next question that's come up is, I didn't notice on your examples south-facing solar insolation windows. In Passive House design, are windows primarily for looking out? Do you not strive to take advantage of solar heat gain?
Yeah, 100% we're looking to take advantage of solar heat gain. So, I was sort of talking about passive solar as opposed to Passive House, and passive solar overdid it on the heat gain. There wasn't enough attention paid to the envelope and air tightness, and then balancing that amount of heat gain with the house. But we take very close look at active gain from our windows, and we think of them sort of as our solar collectors. They are our heaters for our buildings. So we do modeling of each and every window in the house to look and see which windows are ones that provide us net positive gain, and those that provide only loss. So maybe to simplify that a little bit, we all probably know that windows, when the sun is shining in them, they're gaining energy and heat. So that's a good thing when it's cold out. But at nighttime, when it's cold out, those windows also lose energy. So we do intensive study and modeling of the balance window. Really how we get to these low energy loads is through that balance of optimizing that and putting those windows to work where they can most help us, and then trying to minimize those windows that aren't able to help us as much. Although, like I was saying earlier, sometimes we have to maybe put bigger windows in places that are less than optimal from a performance standpoint in order to accommodate, great views and things of that nature. So.
Great, thank you. And next question is, have you or other Passive House designers given presentations to the Colorado Energy Office staff?
Yeah, I know in particular of one other fellow that's been practicing Passive House architecture for quite some time, has definitely reached out to the Colorado Energy Office staff and was making some inroads on step codes and so forth. But I am not sure what the current status of that is. I think some of that work was even the prior administration, but I don't have a current status of that. I have to get back to you on that.
Super, thank you. And I just want to note, this is the Empower Hour, but Greg has graciously agreed to stick around for a little bit longer so we can continue to take a few questions. So thank you, Greg. The next question is, the city of Boulder is in the process of updating their energy building codes. Do you know of cities that have incorporated passive house outcomes and criteria in their building codes?
Yes, so kind of two answers to that, or two parts to that answer. One, there are definitely cities that are mandating passive house. There are not as many in North America. There are considerable amount in Europe, but there are many jurisdictions in North America that are either partially mandating or providing incentives towards meeting passive house standard, or offering step codes towards getting to passive house. But I would tell you the idea of using passive house modeling in lieu of the other kind of modeling we have to do for buildings is becoming more and more accepted in many jurisdictions, including Boulder. So I have a passive house project that's in construction right now in the city of Boulder. And we were able to submit our PHPP energy modelings in lieu of manual J calculations, if that means anything to you. In the city of Boulder was very much on board with that. I also know the city of Fort Collins does the same thing. And there are probably other jurisdictions in Colorado that will as well, but I'm just not as familiar with them. But it's definitely an increasing situation.
Super, thank you very much. And another question is, if somebody, after seeing this presentation, got excited about passive house, either for a house they're building or a church they're building or a commercial building, what would be their first step? What would you recommend?
Well, I would say reach out maybe explore the Passive House Network website. You can also go down a very deep rabbit hole just anywhere on the internet on passive house to learn more. But I would say if you actually have a building project at hand that you're considering, that you get in touch with a passive house professional, either a designer or a builder or both, that has that certification and training, and then reach out to them and connect to help you work through those initial stages of the project.
Super, thank you. Well, we're just a couple of minutes after time, and I don't see any more questions in the Q&A, so maybe I'll hand it over to Mary to either ask a question or wrap up. Go ahead, Mary. Thank you.
I will do both. Thank you so much, Greg. Such interesting stuff and so cool to see the examples. One thing I was wondering about is whether it's obviously these principles can be applied to any building project, it seems, but if someone were doing a remodel, is it possible to start incorporating these principles into an existing building? Or are you better off starting from scratch?
Yeah, no, you definitely can. The starting from scratch question is probably a bigger question than the other part of your question. There is definitely a path towards passive house certification for retrofits, and it's called EnerPHit, EnerPHit, PHI, like Passive House Institute. And so what it acknowledges is that it's more difficult to achieve passive house certification if you are retrofitting. You generally either have to do what we'd call an innie or an outie, meaning you either have to kind of pull all the materials off the inside of your walls and add a whole lot of insulation to them, or you kind of got to pull off the materials on the outside, an outie, and add a lot of insulation to them as a starting point and replace windows. But EnerPHit acknowledges that it's much more challenging to get an existing structure redone and air sealed properly. So the criteria for like the air tightness and the energy consumptions are both softened a bit for EnerPHit projects. As well, there's means to allow phasing. So, for example, oftentimes people might, let's say, be remodeling a house, and this year they're going to replace the siding on the front of their house and replace the windows. So that's a great time to, address the thermal envelope of that side of the house, but maybe they're not touching the other side of the house. And so there's a way to sort of sequence this and phase it throughout the project to ultimately get there in stages as opposed to all at once. So yeah, definitely another approach to getting there. So
Great, thank you.
I also should have mentioned, I forgot, I didn't include a slide, but Passive House Open Days is something that takes place every June and November of each year, where passive houses are open throughout the world. We normally have quite a few passive houses that are participating in that. Right this year, this June, we're a little bit short because of so many other things going on, but that's occurring June. It's like the Friday, the 22nd, I believe, through the 24th, 22nd. Let me get my calendar open here. And again, if you go to the Passive House Network, you'll be able to see this. But so if people want to come tour an actual passive house, that's the opportunity. It's on Friday, the 23rd through Sunday, the 25th. And if you go to Passive House Network and then look up Passive House Open Days, you'll find various tours. I know I am hosting one at my house from 10 a.m. to 12 p.m. on Saturday morning, the 24th, on the north side of Fort Collins.
Cool, that's great, thank you. Good to know, and we'll try to remember to add a plug for that in our newsletter about events. We have another question from Jim. He's asking, is the planting of trees, bushes, xeriscaping, native plants used for shading and wind shadowing?
Most definitely on the shading aspect. So we would be promoting the idea of, say, for example, putting deciduous trees on the south side of our windows to serve as shading devices when they have their leaves in the summertime, and then they allow the sun to come in the wintertime when they lose their leaves. Conversely, a evergreen tree would not offer those same benefits, but deciduous trees are wonderful shading tools. Matter of fact, I think they're the best strategy for east and west facing glazing, because it's very difficult to control the sun coming in east and west glazing, because the sun is at such a low angle when it's on the east-west side of our buildings. The south is easy to control with overhangs, but those east and west exposures are really great to have trees hiding them. As far as xeriscaping and native plants go, it's not part of the passive house principles. Water consumption is of course important to all of us in the passive house world, as well as many other things that aren't mandated by the PHI version of passive house. But I do know there's more this gets too complicated, but there's more than one version of passive house certification. There's another version, PHI US, which does acknowledge some of the water mitigation issues and so forth too. But yeah.
Interesting. Another question I had, Greg, on your home, the exterior appeared to have, I don't know, they look like wood shingles. Are those actually?
Yeah. It's a question we often get. It's actually bark.
Oh,
it's
cool.
Bark siding, and it's comes from a company called Bark House, but it's literally bark harvested from tulip poplar trees. It's not the same kind of poplars we have here in Colorado. This is more of a North Carolina area poplar tree, but basically they're literally stripping the bark off, flattening it, and then making it into shingles, like you said, that vary in size, and you put them up more or less like shingles. But the great thing is it's a cradle to cradle certified product. If that means anything to you, where at the end of its life cycle, you basically can throw it on the ground and it'll just biodegrade. There is no harmful chemicals or added components into it. It just basically will biodegrade. So yeah, got a lot of texture. It even had, when it came, it had vines and even some moss kind of growing on it. Of course, our climate doesn't accommodate that. That stuff kind of dried up. But yeah, thanks for asking about that.
Yeah, neat. All right, well, let's ask again. Is there any other questions from our attendees? We'd love to have you get your questions answered, and if not, I'll go ahead and again, thank you so much, Greg. We really appreciate your time and expertise here. And we'll get the video of this event up on the website shortly. And we do find that a lot of people enjoy going back to review, or people who didn't make it tonight might end up watching that. So again, thank you. And thanks to everybody who attended tonight. We really appreciate it. Again, one more plug for July 11th. It's a Tuesday, when we'll hear from Cameron Brooks talking about the electrifying opportunity of microgrids. And then in August, on the 8th, we'll hear from the Boulder County Office of Sustainability, Climate Action, and Resilience, the director of OSCR, Susie Strife. So again, thanks, everybody. We appreciate you coming, and hope everybody has a good evening. Thanks.
Thank you very much for the opportunity.
Yeah, we appreciate it.
It looks like it came from Merrill, and looks like he is still on if I'm looking at the participant list, so maybe so. So passive solar not only has south-facing windows, but also a mast to store heat and an overhang depending on latitude to block the sun during warmer months. How all does this fit with passive house? So yeah, Merrill, those are all part of passive house sort of basis. Mass is an important thing, particularly in passive solar days. It is not something that's given the same weight in current passive house that it was in passive solar days. It's still something we all acknowledge, but I think we overly relied on it in the past. But all those things about, letting the south-facing sun in, letting it hit, like in my case, a concrete floor to store some of that heat, release it later, is all part of passive house. Having an overhang, as you mentioned, that blocks the sun during the warmer months is definitely a part of passive house. And all of that stuff actually gets modeled in the energy modeling software. So we not only do it, but we model it to prove out if it's working or not. So we might even, put an example, say we have a 3-foot overhang on a window, and we look and see what the performance is with that overhang. Then we might change it to a 3-foot 6-inch overhang and see how that affects the performance, or reduce it. We also look at not only that, but we're looking at the whole house and what all the insulation values are everywhere simultaneously to that same issue, and just seeing what the overall impacts are. So we probably some of my earlier words about passive solar are probably a little too off-putting. I think what we learned from passive solar was all very good stuff. We just know how to do it better now. And the biggest difference is that air tightness factor. We weren't thinking about air tightness when we were doing passive solar. And if you think about a coat that is really got really good insulation, but it's not zipped, it's not very warm. And so if you've got a really good working Gore-Tex coat that's well insulated and it's zip tight, it's so much more comfortable than alternative. So we've gotten better. Yeah.
Yeah, this is Paul Coleman from Empower Future. Greg, I bought my house 8 years ago. It's about a 40-year-old house. And there are a couple of questions about this I have. One is that I'm in an HOA. I wonder how that affects what you do.
Yeah, it actually should not have any direct impact. So you can express passive house in any vocabulary or architectural style. There is nothing about passive house that would prohibit you from doing any style. Where an HOA might come into play is if you're wanting to do something functionally to make passive house work better for you that was somehow in conflict with some of their character criteria, but it would be a case-by-case basis. There's nothing about passive house that would stop you from doing a very traditional piece of architecture, a very modern piece of architecture, or you name it.
Right. My HOA is very particular about the exterior of the home. They don't want you to make any changes at all.
Well, if it's more like a historical kind of condition, it does become, more difficult, like say, we were talking about retrofits and innies and outies a minute ago. And if you're living in a home that's in a historically recognized area, or even if you're you're working on a commercial building that's historical, you're often probably going to be limited to doing an innie version of that retrofit versus an outie, because to do an outie, let's say you have a really old brick traditional building, and the only way to super insulate that thing might be to pull all that and make it airtight would be to pull all that brick off and change out the windows, etc. That's not going to work well in a historical environment. But conversely, you might do that innie where you strip the inside and insulate and seal from that avenue versus the exterior. Windows can be challenging because old buildings, although the windows can often be beautiful, they're definitely the worst piece of technology that we have relative to what we can do today. So historical folks would be very concerned about the proportions of fenestration windows, maybe the detailing, like oftentimes an old window might have a whole bunch of mullions dividing up into little pieces. In that case, those mullions just kill the performance of the window. So in a passive house situation, we might be trying to come up with a solution that either leaves that exterior window in place, and maybe we add another insulative unit on the inside of that window, or maybe we try to come up with a new passive house approved window that sort of mimics a bad word in historical terms, but sort of recreates that look without having like that divided glass into little pieces. Maybe the mullions are inside of the glass, interior to the glass instead of protruding through the glass, sort of thing. So there's no reason that passive house can't be implemented, but there can be challenging circumstances on a case-by-case basis.
Yeah,
if you have a specific
I
example of your
experienced that.
neighborhood. Yeah.
So I replaced all my windows with triple pane windows. And I made them look very similar to the existing windows. So architecturally, they look the same. I also had a lot of air sealing done when I bought the house. The part of passive house that appeals to me now is the air ventilation part of it.
Yeah.
How do you retrofit that into an existing home?
Yeah, it can be tough. There are several products out there. If you're trying to do sort of the preferred version, like to name one manufacturer, Zehnder is sort of the Cadillac of that industry, and that's what I have in my house. But that requires ducting throughout the house. They're very tiny ducts. Don't get me wrong; they're like dryer vent sized ducts, so they don't take as much space as like a typical furnace distribution system would. But you would have to run those throughout the house. So that's tougher in a retrofit. But another, depending on how much of that any work you're doing. But another option is another product, and I may be outdated on this, but I think it's called Sonos. But it's basically, and I think even Zehnder has one of these as well now, but it's a through wall unit where it's sort of, you just poke a hole. I'm so oversimplifying it, but basically you poke a hole through the exterior wall, and this unit is part of this system that pokes through that hole, and it basically just provides fresh air and does a heat exchange on that fresh air through that one source, that one point from outside to inside. So if you have a house with multiple rooms, bigger rooms or something, you might need more than one of these. You might need several, depending on the circumstances, but that's less disruptive than having to run, ducts throughout the entire house. I'm no expert on that solution, but that's another possibility. So,
All right,
but that ventilation is so huge when we're making our homes airtight, and we've got all these fire issues and smoke issues, being able to seal off that smoke and then ventilate properly when when we don't have an active fire and filter that smoke is so huge. So
yeah, thank you.
All right. Well, thank you again, Greg. We really appreciate you being here.
thank you. Hope
Yep.
to see you again sometime.
Okay. Yep, well, maybe at those passive house days, that'd be fun to see.
Sounds good.
Yeah, thank you. Thanks again to everybody. for coming.
Bye
Good
now.
night.